Today we're going to discuss normal distribution, and I'm going to discuss it, and you'll see another one. Okay, so normal distribution. According to our book here, undoubtedly the most widely used model for distribution of a random variable is a normal distribution. Whenever a random experiment is replicated, a random variable that equals the average or total result over the replicate tends to have a normal distribution as the number of replicates become large. So, normal distribution has a probability density function of mx equals 1 over square root of 2 pi sigma times e raised to the negative x minus mu squared over 2 sigma squared, with x being from negative infinity to positive infinity. And it is determined by certain conditions such as the mean, which is mu, and the variance, which is sigma squared. And the notation for the variable is n is mu and sigma's variance. Okay, so now we go on the normal. So this is the graph of the normal distribution. Here we can see the properties that the normal graph has an area of 1 is with the midpoint of mu, which is symmetrical. So this on the other side will be mu plus standard deviation, and the other one is mu minus standard deviation. So in order to use a while ago we have seen the probability mass distribution of the normal distribution, which is quite very long. So we don't need that. So we're just gonna use their table in order to get the value of z. So in order to use the table, we need to consider these properties. So your mean should be 0 and your standard deviation should be 1. So to convert it, that would be z equals x minus mu over standard deviation. It's also the continuous random variable that will be discussed in the next.
Hi, I'm Lian Alexa Vibodomo, and I'm here to discuss the formulas in getting the area on any part of the normal curve. So the first one, in order to get the area to the left of the given value of z, we'll just use the formula probability of z less than ZO, which is the given value is equal to the probability of z. However, in getting the area to the right of the value of z, we will just take its complement, which is 1 minus probability of z. In order to get the area in between two values of z, we will just subtract the probability of z upper minus z lower. For the first example, we are asked to find the area to the left of z equals 1.43. So, I will now use Filipino in order for you to understand much more easier and clearer. So, ayan, may table tayo, di ba? Sa table, yung vertical, yung given sa vertical, yung ones digit, tsaka yung tenths place sa decimal. Pwede natin tingnan yun, yung pa ganon. Tapos, yung hundreds place naman na digit, yung pa horizontal. So, kung makikita nyo sa table nyo, ang area ng 1.43 to the left is equal to 0.9236. So, sa pangalawang example naman, area to the right of z equals 0.89. So, ito yung graph niya. Sabi ko nga, kanina, pag area to the right ang hinahanap, kukunin lang natin yung complement. So, titingnan natin ulit sa table yung corresponding value ng area ng negative 0.89. So, sabi nga sa table, 0.1867. Eh, kukunin natin yung complement. So, 1 minus 0.1867. Ang value, 0.8133. So, for the last example, ang required area in between 1.74 and negative 0.48. In order to get the area in between two values of z, given 1.74 and negative 0.48, isusubtract lang natin siya. So, according to the table, ang probability ng 1.74 ay 0.9591. At ang probability ng negative 0.48 ay 0.3156. Isusubtract lang natin siya. Ang difference ay 0.6435. So, yung last example natin, ang given na mean ay 30 at ang standard deviation ay 6. So, hindi natin may gagamit yung table. Ang gagawin natin, i-convert muna natin sa standard yung value ng z. So, given yung x, i-plug natin siya sa formula na x minus mu all over sigma. So, 22 minus 30 all over 6. So, negative 8 over 6 or negative 1.33. At ngayon, pwede natin siyang i-tingnan ulit sa table. So, ang probability ng area ay ng negative 1.33 ay 0.0918.
So a while ago, we was able to find the area using the value of z. So what if we're given the area, the value, and we're going to find the z. So what we're going to do is find the value on the table. You cannot use your calculator because there's no function in it. So we're going to find this value on the table and just look for the component on the vertical and component to the horizontal. So which would bring you to negative 1.33. But in the case of no exact value, you find that thing, you just find where is the nearest value to that, and that's your answer. And in the special case of having each different value of z is equidistant to the value that you're given to find out, you just add both of the z values and divide into it, and you'll get your answer. That's all. Thank you.